based on a very simple premise. If chemical rockets have reached the limit of their ability, which they have, what would replace them? Because there has to be a new form of propulsion. This goes back 20 years in NASA. One of the NASA administrators, he said, the two major objectives of my term as administrator of NASA is to ensure new forms of propulsion and protection of astronauts from the dangers of radiation. Didn't they do that on Apollo? No, obviously not. So what are the new forms of propulsion? What will replace the chemical rockets, the liquid hydrogen, liquid oxygen, liquid methane, all the stuff that's now used that makes a great show when it takes off because it's clouds of steam, huge amount of noise, very photogenic thing is a rocket taking off. But there are limits to what those rockets can do, like how fast they can go. They have to achieve a speed to overcome Earth's gravity. Now, in order to do that, they have to accelerate the rocket and all that it's carrying, which is quite a lot, to at least 25,000 miles an hour to achieve escape velocity. Trouble is that when you come back to Earth from space, you're coming back at the same speed because you're being pulled in by gravity, 25,000 miles an hour, hence the problem of re-entry. We'll leave that for another time, I think. So what are the other forms of propulsion that can be used? One of the most promising at the moment, and one that I think is being developed, if you've ever heard of the X-37B spacecraft, which is basically a small version of the space shuttle, unmanned, and its missions last anything up to 700 days, nearly 2 years it's in orbit. Well, it's somewhere. Nobody knows actually where it goes. And that has a strange arrangement on the back of the craft. It has a regular nozzle for standard propulsion using liquid chemicals. It also has another nozzle. Now that would appear to be to do with ion propulsion. That's I-O-N, ion propulsion, which is primarily nuclear. And that may be one of the testing that is being done with it, because nuclear power is a very useful form of energy generation. It can be done from quite small fuel components, and the way that the gases are ejected from the craft can accelerate it, maybe not quite as fast as some of the chemical rockets go, not quite so fast acceleration, but it can achieve ion propulsion, can achieve much greater speeds eventually.
This guy says he's made a new anti-gravity device. There's no fans in here, like there's no props or no blades, it's not air. So you can see the grass isn't moving.
Oh, right, yeah, that's good, I like that.
But this is some new machine that this guy has come up with, right?
Very good.
Scott sent me some links to anti-gravity, and I remembered this guy. I've seen this maybe 6 months ago, and I'm going, geez, there's no strings, there's nothing on it. And then he goes back to power supply or something that he has that wire's connected to.
Why is he wearing a helmet? I think maybe there's some ionization going on there that he wants to protect his eyes from or something, right?
Has he explained how it works?
2 counter-rotating discs that are charged with a high-voltage apparatus.
Right. Well, he's basically, the article in Hollis is describing that same effect with fast-moving, rotating particles, right?
The only difference is he's charging these discs with some oscillating high voltage. Like there's a high voltage frequency that's pelting those spinning discs.
Yeah. Like I said, where's the weight penalty to get the amount of power to lift an actual spacecraft?
This almost reminds me a bit of what Lazar said with capacitor plates.
The vehicle he's showing it might be able to do that. But if you take and you put the power, where the power source is coming from, on board the craft, the weight penalty of that is going to be the problem, especially if you're trying to lift the spacecraft. Your weight penalty probably exceeds what current fueled rocket engines are, the weight penalty you get to provide the fuel.
This is interesting when you watch it take off. This is the first time I've ever seen anything like this in my life.
Which just shows it can be done.
Yes.
There are people working on it. I mean, there have been people working on this sort of stuff for many years. In the early 1950s, there was a lot of discussion about anti-gravity work. And then suddenly it all went black. It was all taken out of the discussion. Somebody who does discuss this, not in detail, but describing what is going on, is an Australian guy called Stan Dyer. I don't know if you've ever seen any of the films he's produced. He talks about this as well.
Well, I would love to see these frequencies this guy's using. Of course, he won't tell you, but the plates, what are they made out of? What are those two counter-rotating plates made out of? I wonder. Because you can see them spinning. They're right here. See them? There's two of them, one here, one there, and you can see them spinning in there.
And it sort of moves in a way that a lot of people describe UFO moving, sort of a feather in the wind.
Yeah. I find it interesting that when he pushes it down, how it reacts. Like it doesn't just tip over and flop around sloppily.
It'll have a gyroscopic effect if the discs are spinning fast enough, right?
But sometimes a gyroscope, if they go too fast, it will actually, if you tilt the craft, it will just go like this and flip. So that he's got to have these spinning at the right speed as well. If that had a power supply on board and was flying around inside of a field, you'd think that that would be a UFO the way it just...
Is the power supply that it might not be able to lift. He's got the wire coming up to just a certain height, and then he's got it secured to the ground because it would lift the wire higher than that.
It just amazes me how that thing behaves just like a flying saucer.
Yeah, well, that's the whole thing is how much power does it take? Because it does not have the power, like if the power source was, like if you put a couple of Hasselblad Varda batteries on there, would a couple of those work and would it be able to lift the weight of the batteries? That's the whole point. The power source is independent of the vehicle. And there again, you're back to the weight penalty of rocket fuel, reducing your payload down, right? Or negating it completely.
Very interesting. It's just because I've never seen something actually function like this.
The one thing I can say, though, is if you have a device like what we were just looking at, and it has some benefit, let's say it won't lift a vehicle, but let's say it reduces the weight of the vehicle by half. What would that do to air transport? Now you can carry twice as much. A vehicle could be very large and land on a very short landing strip because you reduce the weight so much. So the wingspan you've got available, if you have a device to do that, you could put it into construction of buildings. You could put that device on there and reduce the weight of it that you're actually lifting and set it up, and the crane puts it in place, right? Many applications, even if it's not practical for space travel, if you have an anti-gravity device that you can provide like that, like think about it on the ground, and you need a large power source to run it. Well, you're not then lifting the power source, you're only providing the power to it, and you can take large, heavy materials and lift them into place by reducing the weight.
This kind